feet, was used simply because that was all the lab had available at the time. These larger frames are for testing load-bearing assemblies, and have hydraulic lifts with which to apply a simulated load. 600 pounds per linear foot was applied to the stacked straw before plastering, but because the load was not reapplied just prior to testing, this was not considered a load-bearing test. Again, 15 or 20 minutes into the firing, plaster begins to crack and, to a limited extent, spall inside the fire chamber. The circular images are the burners on the far side of the chamber. The horizontal rods are temperature probes monitoring conditions inside the fire chamber. Again, as the wall is pulled away, burnt plaster falls away, and a brief burst of flame ensues. For the 1-hour test, the hose stream is applied for 1 minute. Note that the burn area, 10 feet by 10 feet, is smaller than the overall wall surface. This gave us a chance to later compare burnt versus unburnt earth plaster. Here, a garden hose is blasting a section of unburnt earthen plaster, which melts away relatively quickly. Then, the hose is pointed at a burnt piece, which shows substantially greater resistance, indicating that the clay in the plaster had partially vitrified. We had expected the walls to pass at least one of these tests, but in both cases the walls performed far better than was expected, and we learned a great deal more about how plastered straw bale walls perform under extreme fire conditions.